Hello, good day. Well, for today we're gonna have one situation here about the asymptotes. Okay, how can we identify the vertical and the horizontal asymptotes? Okay, and well, when we talk about the horizontal asymptotes, we're gonna need to be focused more about the fractions. Okay, when we have functions with fractions. So here, for example, let's gonna start with the easy part. Let's gonna start with the vertical asymptotes. Okay, here the vertical asymptotes we refer us about the domain. Remember, for example, that we have two situations or two conditions, that we need to understand. The first one is a fraction, okay? Imagine that we have 1 over x, and remember that the x is not possible to have or to be equal 0, okay? Because it's not possible to have the denominator to be equal 0, okay? We are gonna have a undefined function. So for this situation, we are gonna need to find what values from x is gonna transform or is gonna be able to change this to 0. So in this case, when we find these values, we are gonna have the vertical asymptotes. Okay, one situation here is gonna be the vertical asymptotes. Another case is when we have radicals. Okay, when we have the square root, for example, or well, the roots with even values, square or to the 4th or 6th, you know, all these roots. And what is the situation here? Well, here remember that it's not possible to have a negative expression in the square root. So for example, for this case, we need to find what values from the function or from the expression transform this in less than 0. Okay, just because we need to avoid these values. So here, for example, we need to represent, or we have to represent this in an inequality. If you remember, in the first case, we need to represent this like an equation. Well, here it's going to be with the inequality. And for this, we need to find all the positive values, or also, the values can become 0, okay? Remember that the expression here, we can read it like x is greater or equal 0. So, well, that's the situation with the vertical asymptotes. Now, what about the horizontal asymptotes? Here, well, we are going to need to talk about the values that we're going to have with the h. You see now more. Well, the range. Here we want to say that we want to talk about the values that we can take from the y-axis or the function of x, okay? And here also we need to consider like the x has a tendency to be positive infinite or negative infinite, okay? So, what is the first situation? I'm not gonna say it, and like I repeat, here we're gonna be focused about the functions that are represented with a fraction, okay? So, the first situation is when the degree of the numerator is less, okay, than the denominator. So, here, for example, when we have this case, like the degree is less than the denominator, the asymptote is gonna be 0. Okay, as you see, well, here I put some lines, it's like this, then represent the asymptote. Okay, so that's the situation here. The next case, or the next situation, the second one, is when we have the degrees are equal, okay, on the numerator and the denominator, okay, are equal. So here, for example, we need to take the coefficients. When we take the coefficients, we are going to be able to find what is the asymptote. For example, here, 3/4. 3/4 is going to be the asymptote that we have in this situation. And also, here, for example, we can have the third situation is when the degree in the numerator is greater than the degree of the denominator. Okay, in this case, we don't have asymptotes. So when we have this situation, well, we don't have any asymptotes. So let me show you some examples here, so then you can understand better how this works. So the first one, let's gonna say that we have one function, and we have the function is 3x squared minus 1 divided by x minus 2. So the first case, let's gonna try to find the vertical asymptotes, okay? We need to avoid the 0 here. So it's simple, like we say, we're gonna need to create an equation, like we said at the beginning, remember? Here we have a fraction, so we need to find what values from this function become 0. So, the values, for example, in this case, when x is equals to, the function is gonna be 0. So this is gonna be the vertical asymptote. Now, check this case. We are going to have x squared and x to the 1. Okay, here, as you see, we have the numerator, or the degree of the denominator is greater than the denominator. So let's gonna check in what situation is this one. For example, is the numerator greater than the denominator? So it's not the first one, okay? It's not the second one, okay? The third one. So what happened here? We don't have asymptotes, okay? And for this, let me show you one graph, okay? Just so you can understand better how this works. And well, one situation here, only we are checking something related about vertical and horizontal asymptotes, okay? We don't check yet like a obliqual asymptote. That's another for another video. Okay, let me just show you the graph. Okay, so well, if you see here in this graph, let me show you. Here, well, you can see something that I say, like the obliqual asymptote is like this position, but check, we don't have any horizontal asymptote, okay, like we said, and we have one vertical asymptote, like also we said, okay. So here the vertical asymptote is in the number 2, okay. So and this is the graph. So this is the idea, okay. This is the way that you can find the vertical and horizontal asymptotes. Let's gonna check another example. So I'm off here. For example, here the same situation, we have the function 2x squared minus 1 and x squared minus 4. So, like we say, let's gonna start with the vertical asymptotes, okay? X squared minus 4 is not possible to be equal 0. So we need to find what values from the x transform this this equation in 0. So we put x squared minus 4 equals 0, x squared equals 4, and we apply the square root, and we're gonna have positive and negative 2. Okay, so we're gonna have the vertical asymptotes is gonna be x equals 2 and x equals minus 2. Well, just in case if you don't know why we have the positive and negative, just remember the situation. For example, remember what's happened when we have 2 squared, that's gonna be 4, and also when we have negative 2 squared, also is 4. Okay, so when you apply the square root, you're gonna have two values, okay, positive and negative. So that's the situation. And here, well, we found the vertical asymptotes, x equals 2, x minus 2. And here, what about the horizontal asymptotes? Well, check, we have the situation here. The degree is 2 on the top, 2 on the bottom. Okay, so we need to take only the coefficients. So we're gonna be, it's gonna be 2 over 1. Sorry, not 2 over 2, 2 over 1. And obviously it's gonna be equals 1. So the horizontal asymptote is gonna be y equals 2. Okay, and for this, let's gonna check this situation. Remember, just the idea about this, it was the second situation, okay, when the degrees are equal. Just then you remember where was taken this idea. And let me show you the graph. Well, if you see it, this is the graph. Here, well, let me just approach a little more. Well, probably you don't see so clear, but here we have the 2. This is the horizontal asymptote. And here, well, we have the vertical asymptotes, okay, minus 2 and 2. So this is the way. Also, just let me show you. Also, you have this section, okay, of the graph. And these ones are the vertical and horizontal asymptotes. So, well, let's gonna check another problem. Here, for example, we have this fraction, and the same. We need to find the. It's gonna start with the vertical asymptotes. We need to say, for example, that x squared minus 4 is not possible to be equal 0 because this is in the denominator. So it's gonna be, well, x squared. No, sorry. This is the this one. Sorry. Here, we have the x squared plus positive 1, okay, plus 1. So x squared plus 1 and x cubed minus 2x on the top. So the first situation, remember, that is not possible to be equal 0, so let's gonna try to find the the zeros, or let's gonna try to find the values from the x is equal 0. So here, for example, we are gonna take this x squared, okay, plus 1 equals 0, x squared, well, equals minus 1, and here check what happened, okay, because we are gonna have minus 1, okay, so a square root of minus 1 is not possible. So here, for example, I was gonna say that it's not possible to have any 0, okay, in this part of the fraction, and makes sense because here, for example, no matter what value you are gonna put here into the x, no matter if you have for example, positive 2 or minus 2, it's gonna be always positive, okay? No matter if you put a negative number, for example, minus 1 squared, always is gonna be positive, and obviously if you put positive, it's gonna be positive, okay? So here it's not important what value are you gonna put, always is gonna be greater or not equal 0, okay? So here it makes sense. Now, for example, check the situation here. Let's gonna check the degrees. The degrees on the top is third degree, and on the bottom is second degree. So what happened here? Let's gonna remember the theory situation. We have a greater degree on the denominator. So here, for example, as you see, we have the theory situation. The degree of the function in the numerator is greater than the degree of the denominator. In this case, are not asymptotes, okay, are not asymptotes. So here we are not going to have any kind of asymptotes, and well, you saw that in the demonstration. So let me just show you with the graph, okay? Give me a moment. Okay, so as you see, here we don't have any vertical or horizontal asymptotes, okay? We don't have any like that. And here, you see, well, we have this line that is oblique asymptote, but something that we're going to check in the future. But well, this is the idea, okay? Then you understand this situation. So well, let's gonna stop here, and we are gonna continue for the next time. Bye bye.